All right, hi folks, this is Larry Mussolino. I'm recording a video for Objective 6 in MATH026, and this has to do with working with rational expressions and adding and subtracting rational expressions. Now, one thing I want to remind you about when you're adding or subtracting fractions is you must have the same denominator. So to add or subtract fractions, you must have the same denominator. We do a couple of examples quickly with numeric fractions, and I'll remind you about getting the same denominator. All right, let me give you a quick example here. How about 2/7 plus 4/7? Well, notice in this example, we do have the same denominator, which is 7. So the procedure then is keep the denominator the same and add the numbers on the top. So this answer would be 6/7. But what if I had, let's say, 2/3 plus 3/4, let's say? Well, notice I can't add these fractions right now because they don't have the same denominator yet. So you probably remember that what you have to do is find what's called the least common denominator. And the least common denominator is some number that both 3 and 4 will evenly divide into this number. Well, I'm going to use 12 because that's the smallest number I can come up with such that both 3 and 4 evenly divide. So what I want to do then is I want to convert these fractions into equivalent fractions that have the denominator of 12 that I'm looking for. So I'm going to change this to be a denominator of 12, and I'm also going to change the second fraction to be a denominator of 12. All right, well, what I'm allowed to do is multiply each one of these fractions by some quantity over itself. So these two boxes have to be the same. And the same for the second fraction, I'm allowed to multiply it by a quantity over itself as long as these two boxes are the same. Because if these two boxes are the same, I'm really multiplying by 1, and multiplying by 1 doesn't change the value of an expression. So what I say to myself is 3 times what number would get me the 12 as the denominator I'm after? Well, if I put a 4 here, 3 times 4 would be 12. But if I put a 4 in that lower box, I must put a 4 on the upper box. 2 times 4 gives me an 8 on top. All right, let me come over to the second fraction. I need 4 times some number to get me this denominator of 12. Well, I know 4 times 3 will get me 12. But if I put a 3 on the bottom, I must put the same number on the top. Now I'll multiply straight across on top. 3 times 3 is 9. Now I can go ahead and add, because I have the same denominators. You keep the denominator the same and add the numbers on top. 8 plus 9 is 17. Okay, so this is the idea of adding fractions or subtracting fractions. You must have the same denominator. If you don't have the same denominator, you have to take some extra steps in order to get what we call a common denominator. So let's go to this example. This example, actually, we do have the same denominator. So that's good news. Well, the rule is keep the denominator as is. And now I'm just going to go ahead and subtract the numerators. So that's going to give me c squared minus 64. But for any of these answers, we want to simplify the fractions as much as possible. You probably remember you do the same thing with numeric fractions. If you had a numeric fraction, you would usually simplify the fraction at the very end of the problem. Well, you might remember c squared minus 64 is the difference of two squares. So I'm going to rewrite that as c plus 8 over c minus 8. And I have a c plus 8 on the bottom. Well, now I have the same quantity, c plus 8, appearing top and bottom. I can cancel that out. So the final answer here, I'm left with just c minus 8. All right, so in this example, you can see we had a common denominator. All right, let's go to a different example where we don't have a common denominator. And we're going to have to take some extra steps in order to get the common denominator that we're interested in. Okay, let me go to a different example. Let's take a look at this problem. Actually, before I do that one, let me do an example. Let's take a look at one here. All right, well, this example is asking me to take the starting expression they're giving me, which is 5 over y plus 2, and they want me to end up with a y minus 7 times y plus 2 on the bottom. Well, if I'm starting out with y plus 2, but I want to end up with a y minus 7 on the bottom, that means I'm going to have to multiply by a fraction y minus 7. But we just mentioned that whenever you multiply by a fraction like this, really you've got to multiply by a fraction equivalent to 1, which means I need to put the same y minus 7 on top. So this is going to be 5 times y minus 7. On the top, I could write this. I could take the 5 and multiply it inside. So I could put 5y minus 35 as the top part of this fraction. So for this example, what you had to recognize is to go from this denominator we started with to the denominator they gave us, we had to add in, or excuse me, we have to multiply by this y minus 7 on the bottom. But if you multiply by y minus 7 on the bottom, you must do the same thing on the top of the fraction. So I needed to include a y minus 7 on top. All right, let me go to another example. Let's take a look at this example. It's asking me to find the LCD, that's least common denominator. By the way, folks, I want to remind you that when you're working on these kinds of problems, remember you have these explanations available. So these explanations are going to show us the exact steps that we need to work through these problems. All right, well, all they're asking us here is to find the least common denominator. So they want us to look at these two denominators and find the least common multiple. All right, well, the first step is to take each one of these fractions and factor the denominator. So let me take this first fraction. I'm noticing there's a 2 as a greatest common factor. And the other one has a 3 as a greatest common factor. All right, now I want to find the least common denominator. You can also think of it as the least common multiple of the denominators. Well, what it's going to turn out is I'm going to need to include any unique factors like x minus 4. Now, because x minus 4 shows up twice, once in this fraction and once in this fraction, I'm only going to use it once. So the LCD is going to include x minus 4. But then I also need the LCD for 2 and 3. So it's almost like you're finding the least common denominator for 2 and 3. Well, remember, that's a number such that both 2 and 3 evenly divide. Well, that number is 6. So this is the answer that they're looking for. This is the least common denominator. So if I was going to add these two fractions, they're not asking me to do that in this problem. But if I was going to add these two fractions together, notice the denominators are not the same right now, so I couldn't add them. I'd need to find the least common denominator, and that's what we just figured out here. So this problem was intended to just give you a little practice with finding least common denominators. All right, let's go to why don't we add some fractions that don't have a common denominator. All right, so notice they're asking us to add these two fractions together. I can't add them right away because they don't have the same denominator. So I'm going to bring up the example so we can take a look at this. All right, so here are the two fractions they're giving me. -6 over 5w to the third and 7 over 4w squared. Well, I need to find a least common denominator to start off with. All right, let me look at the numbers first. I'm seeing a 5 and a 4 on the bottom. So I need a number such that 5 and 4 evenly divides into that number. That number is going to be 20. All right, now let me look at the variable part. I'm seeing a w to the 3 and a w to the 2. Well, when you're looking for the common denominator or the least common multiple, you want to select the variable that has the highest exponent. So because I'm seeing a w to the 3, that's what I'm going to use as the LCD. So the LCD is 20w to the 3. So what I want to do is I want to take this first fraction and change it to have this denominator of 20w to the 3. So I want to end up with a denominator of 20w to the 3. So I'm going to use that little trick that says I'm going to multiply by some quantity over itself. Remember, these two boxes are going to have to be the same. All right, well, let me look at my denominator. It's 5w to the third. Well, if I multiply that by 4, I'll get the denominator 20w to the 3. So I'm going to put a 4 on the bottom. But remember, I got to put the same quantity on the top. So I have to put a 4 on the top. Now let me multiply straight across. That's -24 on top. All right, I'm going to do the same thing for this other fraction. I want to end up with this denominator 20w to the 3. So I'm going to multiply this by some quantity over itself. Remember, these two boxes have to be the same. All right, well, let me look on the bottom. 4 times what number will get me this denominator 20? Well, that's a 5. W2 times what will get me this w to the 3? Well, that's a w to the 1 or just w. But if I put a 5w on the bottom, I have to put a 5w on the top as well. I'm going to multiply across on the top. 7 times 5w is 35w. All right, well, now I have this worked out as an addition problem with the same denominators. Let me write it. Here are the two fractions we have now. All right, well, I have the same denominator, so the rule is keep the denominator as is and add the tops of the numerators, right? Add the top, -24 plus 35w. And that's the answer we're after, -24 plus 35w over 20w to the 3. Remember, folks, you can use this explanation to show you the step-by-step analysis for any of these ALEKS problems. All right, let me go to another example. Let's go here to finding the least common denominator. All right, now, of course, these are a little tricky because the denominators are quadratic expressions. All right, well, here's what I'm going to do. First, let me try to factor each one of these denominators, and then I'll be able to figure out what the common denominator will be. All right, so let's take this first one. I'm going to make a little more room here. So let me take this first fraction. It's 9x over 2x squared minus 7x plus 5. All right, well, I'm going to try to factor this denominator as the multiplication of two binomials. All right, well, I can either use the AC method or I can use the trial and error method. Well, I know that I'm going to need a 2x and an x in front because this 2x will multiply that x to get me back to the 2x squared. And I know that in the back of the parentheses, I need two numbers that have to multiply to 5. So I'm going to try to put a 5 and a 1. If that doesn't work, I might have to switch the numbers around and put a 1 in front and a 5 in the back. But I'm going to try this first. I also know that I'm going to need two subtractions back here. The way I know that is -5 times -1 will get me the +5. But then when I add the middle terms together, I have to get a -7x. And if you were to multiply this back with a FOIL multiplication, you would see that we've done the factoring correctly there. All right, let me go to the second fraction. It's 5 over 2x squared minus 9x plus 10. All right, so again, I'm going to try to set up the factoring as two parentheses, two binomials. I'm going to put a 2x and an x in front, because this 2x multiplying that x would get me back to the 2x squared. And now I know that the numbers in the back have to multiply to get me 10. Well, for two numbers to multiply to 10, I can either use 1 and 10 or 2 and 5. And again, you can use trial and error. You can use the AC method. Turns out if I put a 5 in front and a 2 in the back like this is going to give me the factoring I want. All right, now I need to figure out the least common denominator. Here's what I do. I write, to get the least common denominator, write out the multiplication of the unique factors you see. Let me explain what I mean by that. Let me come up here. I have a 2x minus 5 and an x minus 1. Those are different, so I'm going to bring those down with me. Let me go to this other denominator, 2x minus 5. Well, I already have that here, so I'm not going to repeat it, but I do have x minus 2. That's new, so I'm going to bring the x minus 2 down. Turns out this is the answer for the least common denominator. You can see the answer is written out here also. So again, what we did is we factored the denominators as much as possible, and then we wrote out the multiplication of all the unique parentheses or the unique factors that we observed for each one of these two starting fractions. And again, if they had asked me to add these fractions, which they didn't do here, we'll do an example of that in a second, but if they had asked me to add these fractions, I could not add as is because these denominators are different. I would first have to change each one of these fractions to an equivalent fraction with the same denominator, and this would be the least common denominator that I'd be using. And I would have to change each one of the starting fractions to be a fraction with this least common denominator. All right, well, let's do an example of that. So let me let's do an example. Let me get an example. Where we can find a common denominator and add them together. Why don't we do this example? Let's take a look at this one. It says adding rational expressions, and these have different denominators. All right, well, I know these are different denominators. So first step is I need to find the least common denominator. Then that'll be step 1. Step 2 is change each fraction to have the least common denominator. Then the last step will be add the fractions together. All right, so let's find the least common denominator. Well, here are the denominators I'm seeing: 2w squared y and 6wy squared. All right, so let's find the LCD here. Let me look at the numbers, 2 and 6. So I'm looking for a number such that 2 and 6 can evenly divide into this number. Well, that's number 6, right? Because 2 and 6 both evenly divide into 6. All right, now let me look at the letters, the variables. Well, I'm seeing a w squared and a w to the 1. Well, remember, you want to select the highest exponent you see for the common denominator. So I'm going to pick w to the 2. Now let me look at the y variable. I'm seeing a y to the 1 and a y to the 2, but again, I want to select the highest exponent I see. So this is the common denominator. All right, so here's what I'm going to do. I'm going to take this first fraction, and I want to end up with this common denominator of 6w squared y squared. And then I'm going to take the second fraction, and I also want to end up with the same denominator, 6w squared y squared. Now remember, you're allowed to multiply each one of these fractions by some quantity over itself, as long as these two boxes are the same. Do the same thing over here. All right, well, let me go to the first fraction. I need 2 times some quantity to get me to the 6. So I'm going to put a 3 here. I need w squared times something to get me w squared. Well, I could put a 1 here, but I'm not going to bother putting a 1. I already have a w squared, so really I'm just going to leave that as is. But now I need y times something to get me y squared. Well, that means I need a y here, because y times y is y squared. Well, if I multiply the bottom by 3y, I've got to multiply the top by 3y as well. So if I multiply straight across, that's going to be negative 15y on the top. All right, let me go to the second fraction. 6 times some quantity gets me 6. Well, that's just a 1. W times what would get me w squared? That means I need a w here. Y squared times what would get me y squared? Well, that's just a 1, but I don't have to bother writing a 1. So all I need is a w on the bottom, but that means I need a w on the top as well. So now I'm going to multiply across on top. That's 7w. Finally, I'm going to add the fractions. Actually, here it's really subtract fractions in this example. I now have the same denominator. So you keep the denominator as is. And I'm going to add the numerators. Add the top of the fraction. So that's going to be negative 15y minus 7w. Okay, so again, as a reminder, if you're adding or subtracting fractions, you must have the same denominator. If you don't have the denominator, like this example, we had to figure out what is a common denominator we could use. And then you've got to change each fraction to an equivalent fraction that does have the common denominator. Then at the end, you can add or subtract the fractions because you do have common denominators. All right, hope this is helpful as you're working in Objective 6. Please let me know if you have any questions along the way.